You've been learning all about solving polynomial equations. Before we move on, let's talk about a few things that we want to make sure that we remember. First, roots, zeros, and solutions all mean the same thing. What they mean is to find the values of x when y is equal to 0. Also, we can do this by completely factoring a polynomial and setting each factor equal to 0. Then we learned some strategies that we can use, especially if we can't factor easily from the beginning. One of those strategies is to use synthetic division to start the factoring process. Then we can continue to use synthetic division, or we can factor by grouping, or sometimes it's easy to factor. And if one of our factors is a quadratic, and it's not going to be easy to factor further, then we can use the quadratic formula. But using the synthetic division to start the factoring process implies that we know one of the factors. Sometimes we don't know one of the factors. Sometimes we're only given the polynomial. What do we do then? Well, then we can use something called the Rational Root Theorem. So what exactly is the Rational Root Theorem? Well, the Rational Root Theorem says that the possible rational roots of a polynomial are found by writing a fraction, both the positive and negative, so plus or minus, that contains the factors of the constant in the numerator and the factors of the leading coefficient in the denominator. A lot of words. What does that mean? Well, it means that we're going to write a series of fractions, plus or minus the positive and negative. Each fraction will be composed of a factor of the constant in the numerator and a factor of the leading coefficient in the denominator. Now, these are going to tell us the possible rational roots of the polynomial. Not all of the possible rational roots are rational roots. However, you won't have any rational roots that aren't possible. Again, this is confusing. So we're going to do an example, but I want you to know that you're going to want to pause and re-watch as we do the example. Okay, here's our polynomial, p of x. P of x is equal to 6x to the 4 minus 13x cubed plus 13x squared minus 39x minus 15. Hopefully you see right away that you cannot factor this, not directly the way that it's written. So if we wanted to solve this polynomial, we would need to find a way to start synthetic division to help us begin factoring it. But since we're not given one of the factors, what we need to do is find all the possible rational factors. And then, from there, we could start using synthetic division to start factoring. But how do we find the possible rational factors? Well, we're going to do the plus or minus. We're going to find the factors of 15 to put in our numerator and the factors of 6 to put in our denominator. So the factors of 15 are 1, 3, 5, and 15. And the factors of 6 are 1, 2, 3, and 6. What exactly does that mean? Well, let's take a look. What it means is that we can write some fractions. 1 over 1, 3 over 1, 5 over 1, 15 over 1. We can write 1 over 2, 1 over 3, 1 over 6. Can you see this is going to get confusing, isn't it? We have 3 over 2, 3 over 3, 3 over 6. Do you see what I'm saying? Confusing, right? Well, let's go on. Let's write these out. Highlighting them makes it look more confusing. So what do we mean? We mean that we can have plus or minus 1 over 1, which is 1, and plus or minus 3 over 1, or 3, and plus or minus 5 over 1, or 5, and plus or minus 15 over 1, which is 15. That takes care of all of our numerator over the first factor of our denominator. We're going to do the same thing, all factors of the numerator over the second factor in our denominator. In other words, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and plus or minus 15/2. Now, these are already in reduced form, so we're going to leave them like that. Now we need to take all of the factors in the numerator and put them over the 3 factor in the denominator. But we're not going to repeat anything. In other words, we can do plus or minus 1/3 because that's not a repeat of a possible rational factor that we already have. But if I did plus or minus 3/3, that's the same thing as plus or minus 1, so I don't have to write it again. Then I go to plus or minus 5/3. That's not a repeat of something that I already have. But plus or minus 15/3 is, because 15/3 is the same as 5. You might want to pause here and replay this part before you move on. Now we've taken care of the 3, so I need to take care of the 6. That means we have plus or minus 1/6, plus or minus 3/6, but 3/6 reduces to 1/2, so I don't have to write it again. Plus or minus 5/6, and plus or minus 15/6. But when you reduce 15/6, you should get 5/2. I already have plus or minus 5/2, so I don't have to repeat it. In other words, we have now found all of the possible rational factors. That's quite a few of them, isn't it? What do we do with that now? Well, from here, I want to take 1 minute to remind you of something that I said that you might have missed it, and that is this. We do not count duplicates more than once. In other words, when we got the same factor, such as 3 over 3, which reduces to 1, we didn't write it twice. From here, we can start guessing and checking to find which one of these is an actual factor.